Welcome to Love and Loss, the Symfony security play. Also welcome to Portland. I wish we could have had this kind of weather for you. I'm sure the brew cycle is still going. Wait until after the talk to run out the door. I'm from Portland, which is why I welcome you to Portland. I'm Kris. I'm kind of a big deal. Honestly, I would rather be on the floor in a fetal position right now because this is really outside the box in terms of conference presentations, and I have no idea if it's going to work. So, thanks all for coming. I'm the lead developer on Ascetic, which is an asset management library for PHP. Also lead on Buzz, which is an HTTP library. And Spork, which implements the jQuery deferred API in PHP over the process control forking functions. All that stuff's on GitHub. My day job is at OpenSky. I've been at OpenSky for almost 3 years. OpenSky has been using Symfony 2 since back in those before it was stable, and Jeremy can testify to that. He's in the back there, we're OpenSky alum, and yeah. So OpenSky is a great place to work for me. They are heavily invested in Symfony and a lot of really cool open source technologies in the PHP community. And the technology team is given permission to do things right. So it's a great place to spend your days trying to build something awesome and build it well. So we're going to talk about security. Who has ever who has ever looked at the code inside of the security component? And who felt good afterward? So it's security, authentication, and authorization is a very complex problem to solve at the framework level. And so that's a lot of what you see in there. There are a lot of concepts inside of the security component, and I'm going to walk you through them all, or not all of them, some of them. Here are some things people have had to say about the security component. It's not easily accessible. I wish it were not there. I wasted a weekend. Maybe I just won't use it. So this is the TriMet map for the city of Portland. And has anyone used TriMet, the Max, or the Bus since they've been here? Okay, good. So you memorized the whole map first, right? No? So you don't have to understand something top to bottom in order to use it. You need to know just as much to get what you're trying to do done. So you will not be a master of the Symfony component at the end of this talk, but I'm hoping you at least a little bit know how to fish. So I'm not going to show you how to configure the Symfony component. We're not going to do anything in YAML. I'm going to talk about the core concepts inside of the component so that you have a sense of its inner workings, and whenever you come to that next point in your development where you need to open up the Symfony component and do something in there, you will know where to start and know who the major players are. And this is, like I said, outside the box, so I'm hoping that we will have a little bit of fun. With that, I want to introduce Nathan and Leon over here. Nathan is a good friend of mine, and I've never met Leon before.
speech, Kris.
They're from Curious Comedy, which is an improv group in town. Is that right? Is that a good summation? All right, and so Nathan and Leon here are going to act out the security component for your enjoyment and hopefully edification. We're going to do it kind of like this. I couldn't find a picture of someone actually peeling an onion, but we're going to start here, and then we're going to go here. And we're going to talk about this. And then we're going to talk about this part. And then finally, that part, if we get to it. Or, if you prefer, we're going to start here. We're going to talk about that part. Down here, and if there's time, we're going to talk about that part. Okay. So the HTTP kernel, this is the backbone of the Symfony full stack framework. This is how a request comes in and turns into a response and goes back out. And that happens through a series of events. We've got the kernel request event, where you can look at the request before much else happens. Once you determine the controller, you can look at the controller. You can provide a view if the controller doesn't return a response. You can look at the response before it goes out. And then finally, after the response has been sent, you can watch the termination of the kernel. There's another event in there if something goes wrong, the exception event. So the arrows you see now are a pretty typical flow. This is probably what 80% of your requests look like. So if something goes wrong, you might get something that looks more like this. Or if you have something going on at the very top of the stack, you might just skip a whole bunch of it. So the motto of the HTTP kernel is get the response and get out. As soon as whatever gives a response, you turn around and send that back to the client. So I'm going to zoom in on the kernel request event here. This is the first event that is dispatched. It comes in, it passes through the router. The router is going to look at that request and determine what controller should probably be used. And then after the router is this is the firewall. So the firewall, this is the security component right here. This is authentication and initial authorization of a request happens right here. It's just a listener hanging on to the little chain there. So like I said before, as soon as there's a response, get out. Get the response and get out. So if you look at it from that angle, if your firewall provides a response and your controller is called, which is the same as access being denied to that controller. So I have a little code. This is your yes firewall. So if this is the listener that's attached to your event dispatcher, and this is called, it's not doing anything, so the request is going to be allowed to go straight through. This is always saying yes. So do you guys want to do a little something for us?
So quick show of hands, just because Leon's a mechanical engineer, and I'm a technology salesperson. So just to get a sense of how technically savvy and whether or not we're on the same level, how many people in here, just by a show of hands, have used either an Apple or a Windows-based computer? Excellent, okay, so we're right there,
Was it Sun Microsystems in the back? Is the gentleman who didn't raise his hand?
Yeah, it's a Java. Excellent, so for this, I'm going to be the function. And this is our user request. Functions are going to be always indicated by the fact that we're wearing our handy-dandy Symfony name tags. So for this, it would look something like,
Hi, I was wondering if maybe Kris could come out to play.
I always say yes.
Yeah!
Thank you. Thank you.
Makes total sense, right? And then you have the firewall that always says no. Still, this is just a listener that's listening to the kernel request event, except it always says no. Gentlemen.
Hi, I was wondering if Kris could come out to play.
Go away!
Of course, your logic is probably a little more complicated than that. Perhaps you only want people whose names start with Q.
Hi, I was wondering if Kris could come out to play.
I'm sorry, what's your name?
Quentin?
I always say yes!
Yeah!
Okay, moving on. So you can code everything inside of that listener. If you wanted to, you could implement an entire security component just inside of that little listener and handle all of your logic there. We can't do this at the framework level. Maybe your site is simple enough and you're new enough at this that you would do it that way. But we need to we need to have extension points at the framework level. So the way we do that is by providing security listeners. So once that request comes into the firewall here, we actually have our own little round table with a whole nother set of listeners there. So there's kernel request, it comes into the firewall, and then the firewall has its own event system, and there are listeners that are attached to that event dispatcher. So here's that firewall that works with listeners. He's got his own team of listeners. The request comes in. He'll cycle through everyone who's sitting at that table, ask each of them. As soon as someone says no, so if that event has a response after talking to that listener, we're done. We return. And yeah, no, that's correct. Okay, and then so those yes and no firewalls now become yes and no listeners. Here's the yes listener. Here's the no listener. It's very similar to what we just saw. And here's the listener that only lets you in if your name starts with Q.
So can you three be my team of listeners? And basically, you got yes or go away, right? Okay.
Hi, I was wondering if Kris could come out to play.
Just a second. Hey, can Kris come out and play? Yes. Yes. Sorry, what's your name?
Wexelmeyer?
Name seems to be Wexelmeyer.
Yes.
Yes!
All right! Oh, that's so great.
Thank you.
And thank you.
So, everyone said yes, which is great. The request got through. Each of these listeners here is going to be paying attention to something different. So if I come to the door and I say hello, then one person might say, the first person might say no, but the second person might have said yes. So who can point out the flaw in this, other than the obvious, what's wrong with this code? Ryan. It doesn't, if the first listener says no, then you'd never get to the second listener. So that second listener might as well just not be there. So the problem here is that we are conflating authentication on the one hand and authorization. And then we need to break those two apart. Authentication is, are you who you say you are? And authorization is, are you allowed to do whatever it is that you've come here to do? So we've separated these two apart. So so if Louis is the authentication, and I don't know your guys' names, if you were authorization, and let's say you're on opposite sides of the room, we're going to need some means where they can communicate. They need to stay on the same page. If Louis says this person is who he says he is, then these fine listeners over here need to know that they saw him and that he said that. So we have something called a token. Token is the language of the security component. This is what gets passed around so that everyone can stay on the same page. And it's kind of encapsulated for anyone to access in the security context. A token is also kind of like a driver's ID. So, you guys like it? So now the listeners, you guys down here, your job is to authenticate. And for now, all that means is taking the request that's coming in and take whatever pertinent information is on that request and put it onto the token. So you map from the language of HTTP to the language of the security component so that then you can all be on the same page using this token. The listener's map from request to token. Here's my little diagram. Your request comes in. Over here is HTTP land, and inside of the core here, this is the security world, and everything in there happens with a token. The token comes out at the end and turns into a response and gets sent back. Optionally gets turned into a response because remember, if the security component does not provide a response, that's the same as letting the request go through to whatever it came here to do. So we have core and HTTP up here in the black, and you can look inside of the code, and it's organized in this way. So if you look at the subpackage core, this is core, right? This is all of the objects, very abstract objects that deal with authentication and authorization. There's nothing in here that is aware of HTTP. There are no dependencies to other Symfony components inside of the core package. However, inside of the HTTP subpackage, this is where we are aware of requests and responses, and therefore have dependencies on the HTTP foundation component, the HTTP kernel component, and the event dispatcher. So that's why the code is organized like it is. Core is just abstract solutions for the problems of authentication and authorization. HTTP is that layer that takes a request, puts it into a token, anything that knows about requests and responses. So here we are back at that round table. We've got the firewall up here in the top left, and then two authentication listeners here. A request is going to come in. The authentication listener A is going to get first crack at it. He can either choose to do something with that request, send it into authentication, or he can pass, and it'll go off to the next one, and that guy can look at it. Since the authentication listeners are now just mapping layers, they map from HTTP into the language of security, the token, we now have a new object called the Authentication Manager, who is in charge of making that decision of whether or not this person is, in fact, who they say they are. In code, it looks something like this. We've got this authentication listener. It takes the request off of the event. We're going to take the username off of that request and add it to a token. Pass that token into the authentication manager, or the auth man. And then when the token comes back out, we'll put it on the context so that it's available for any other services that want to work with they want to know authentication state. The authentication manager, again, he can always say no, which is not returning a token. He can always say yes, or just maybe, he could only say yes if the guy's name starts with a Q.
Okay. Identity token. Hey, auth man!
Who seeks the counsel of Othman?
Just me, listener A. I was wondering if you could validate that for me. He wants to have Kris go out and play.
I can't read what the name on this is.
Oh, I'm gonna have to always say no.
That was a no?
Yeah,
Oh. What is this?
that's the token.
Okay. Clear as mud. Okay, so the Authentication Manager is responsible for authenticating the token. The token comes in from the listener, and there's a token there's a flag on the token, a switch. This token is authenticated, yes or no. And so the Authentication Manager is responsible for flipping that switch. Now, again, there are a lot of ways to make that decision. You might want to do it based on one criteria or another criteria. So at the framework level here, we need to have another extension point here so that you can come in and provide your own authentication mechanism. And those are the authentication providers. These are actually the guys that do all of the actual authentication work. So the authentication listener, there can be many of them. So for example, a common example is, you sign in with your username and your password, or you sign in with your Twitter ID if you click sign in with Twitter. So one of these authentication listener A, if that's looking for username and password, it would look at the request, it would take the username and password, it would put it onto a token, and then it would send it into the authentication manager. Whereas authentication listener B, it would look for your Twitter ID, and take that and put it on a token and pass it in. Comes into the authentication manager. So the authentication manager is going to be fielding all of these requests for authentication. All of these tokens are going to come in with a lot of different types of information on them, username, password, or Twitter ID. And so he's going to have a team of authentication providers here. So if something comes in, he's going to show it to each of these guys. If they want to take a crack at it, they can. If not, they can pass. Same idea as the security listeners. Optionally, behind each authentication provider, there can be a user provider. So that authentication provider can be the glue between the users we have in our system and the username, password, Twitter ID, whatever credentials come in on that token. And so that authentication provider will reach into our user database and put that user on the token. So let's take a stroll. This is the token here. The request came in, and we've put the information that we have onto this ID. It gets sent down to the authentication manager. He's going to pass it along to his boys here. This authentication provider will then work with whatever user provider is behind it. He finds that user, puts it on the token. The token is now switched to authenticated, and it goes back up to the listener and either, actually that's it, yeah, because we're only doing authentication here. User providers are actually optional. What's important is that authenticated switch. So the user providers are just providing a wrapper to give you access to that repository of users in your database. If you have one, most common, you have one table or one collection of users. And so you can have one user provider and give all of your different authentication providers access to that one user provider. So it facilitates reuse. Let's look at some code. So here's our authentication manager now. You can see that he's got a team of providers. Token comes in, he's been asked to authenticate it, and he's going to show that token to each of the guys on his team and ask if they want to do anything with it, if they support this kind of token, or if they speak the same language as this token that's coming in. If if they speak that language, then he just has that guy handle it. Inside of that authentication provider, he gets the user off the token. This is where the actual authentication happens. This is a really dumbed down. There's actually no authentication happening here, but this is where you would add mechanisms to check the password against the hashed password that you have in your database. That all happens here inside of the authentication provider, who's on the Authentication Manager's team. And then behind that authentication provider, there may be a user provider to provide an object-oriented wrapper to your database. You guys want to take a swing at it?
Absolutely. Absolutely. Crystal clear.
Mud. Oh, jeez. I'm going to have to call this one in.
Hi, you've reached the authentication providers. For Spanish, press 1. For French, press 2. For German, press 3. For Chechen, press 4.
English.
For Brazilian Spanish, press 5.
English.
For Portuguese, press 6. For Pig Latin, press 7.
English.
For JavaScript, press 8. For jQuery responses, please go back to the main menu. For English, press 9.
Thank you, thank you.
Hi, this is the authentication provider for English. My name's Tom. How can I help you?
Hey Tom, this is Offman down in the...
How's it going?
It's going great, it's
Got
going...
a token for me?
I sure do.
Awesome.
Yeah, I can't really make this out. It looks like, I think it's Quentin.
Oh, Quentin, great guy. Just a second here. We actually just looked him up in the user database the other day. Yeah, I'm going to go ahead and authenticate that
All right.
for you.
All right,
Get
great.
that switched on.
All right, perfect. Thank you very much.
Glad to be of service, Offman.
All right, talk to you soon.
Bye.
There's some guy who wants to play with you outside. I don't know.
Perfect. So those are the major players inside of the authentication side of the security component. We've got your listeners here. These listeners map the client data from the request to the token and then pass that along into the authentication manager, who's responsible for making that decision. And then once it's all done, the listener is going to update the state saved on the context for other services to access. The authentication manager in the middle there is responsible for making the decision, and he calls on the appropriate authentication provider. Each of these authentication providers does the actual work of authentication. They look at the client data that's come in on the token and handle that in whatever way that provider is designed to handle it, and then eventually marks the token as authenticated if that's the case, or does not if that is the case. And if the token is authenticated, you can optionally attach the user to that token so it can be passed around as well. And the user provider is what we use to access those users from the database. So that's the authentication side. Excuse me. So we zoom out a little bit here. You can see we've got the authentication going over there. There's two authentication listeners. Next, we're going to talk about authorization, which happens right here. Authorization is, are you allowed to do what you've come in requesting to do? And again, this is just another listener. So we have the round table of listeners around the firewall, who he seeks counsel from when he has to make these decisions. And at the end, after a request goes through the authentication listeners, finally the request will come to the authorization listener, who decides whether or not the request is allowed to do what it has come to do. So we already have the token is authenticated or not, that switch has been flipped, and it comes into this listener and he decides. So we're back to where we started, really. At the top, we had the firewall. It was always saying yes. It was always saying no. If you're saying yes, you're not doing anything, like you see here. If you're saying no, you're providing a response, some kind of no response. Here it's a 403 forbidden. And the HTTP kernel, as soon as it has a response, it stops everything else. So this would prevent the controller from actually being called. You guys want to do this one again? Say yes.
Yeah. Who comes before the authorization listener?
It's me, Quentin. I was just wondering if Kris could come out to play.
Let me see.
You know, the guy back there said everything was...
Sorry, Quentin. Go away.
So we break this down a little bit more. I'm running out of time, so we'll step through this pretty quickly. The access map is the first member of the authorization listeners team. The authorization listener has a request and it has a token, and it has to somehow compare the two and decide if this token is allowed to do what this request wants to do. So we're going to look at that request and map it to a set of requirements. So this could be a set of requirements as simple as I know who you are, yes or no. You have a certain role. You are an admin, for instance. And then once it has that set of requirements, it passes the requirements and the token into the access decision manager, or the gatekeeper. Gatekeeper here decides whether or not this token meets these requirements. In pictures, there's the authorization listener on the left, comes through the map, and then it comes into the decision manager. The decision manager also has a team. This is another extension point in the framework. If you want to encapsulate your own authorization logic, this is where you're going to want to do it. You add a member to the decision manager's team. And those members are called voters. So if you have some special logic where you only want this type of person to be able to perform this function, you could encapsulate that logic in a voter and put it here. In code, we have the access listener here. The access listener has access to the context. This is where we put the token earlier, where the authentication listeners put the token so that other services have access to it. So we have access to the context, therefore the token. We have access to this map guy who's on our team and looks at the request that comes in and says, well, if he wants to do that, he's going to need this, this, and this. And then finally, it has the access decision manager who's going to actually make a decision about whether or not this token meets those requirements. This is the access map. It can be something very simple. And then the access decision manager, you'd have the token and then the requirements, and we'd pass each of those, we'd ask each voter to express an opinion, and as soon as one of those voters says yes, typically the access is granted. And this is what a voter might look like. The vote comes in, we look at the requirements, we look at the token, we decide. Yeah, you want to take a swing?
Who comes before the authorization listener?
It's me. It's Quentin. I was wondering if Kris could come out to play.
Just a second. I'm going to have to pass through my map. How's it going, decision maker?
Oh, it's been a long day, long day. Let's see. I'm gonna have to go to my voters for this.
So, voters, by a show of hands, is Quentin who he says he is, and can he go and play with Kris? Yes? All right, well, one person said yes, so I'll allow it.
Back through the map.
Oh, nice. Sounds good. Go on in.
It's been a long journey.
And that more or less is the authorization that happens at the top of each request. So in summation, I just want to reiterate each of these extension points, because now that you have this understanding of the security component in your bones, I want to talk about each of those points where in your development you might, you will most likely need to interact. And it's basically all the teams that I talked about. So the firewall, he's got a team of listeners. These listeners are responsible for mapping information from the request onto the token, so that this question of authentication can then get answered using the security component. So if you want to look at the username and password, you're going to have to take that off the request, put it on a token, and then send it in. That's the role of a security or an authentication listener. That token gets sent into the Authentication Manager, which has many authentication providers. So now that the information from the request has been put onto the token, there need to be authentication providers that know how to decide whether or not this information on the token is valid. So if it's a username and a password, that authentication provider is going to look at that on the token, and it's going to pull up that user and compare the two passwords, maybe run some additional checks. Has this user's account expired? Is this person suspended? That all happens there. And the authentication providers may rely on a user provider for that. They don't have to. If you're writing your own authentication provider, you can stop there. Most of the times you can just inject your user repository right into your authentication provider. You don't have to go through that extra step of creating a user provider. All that has to happen inside the authentication provider is that the decision has to be made. And that distinction of that you may or you may not, if you choose to use a user provider, is I've been trying to demonstrate that with each level of the onion that we've peeled back. We could have stopped at just a listener and always said yes or always said no. You can write your own security component and just put it in a request listener and say yes or say no. But hopefully you understand why each of those layers is there. And lastly, there's the team of voters that work for the Access Decision Manager. These guys, so you can have a voter that, if the person is authenticated or not authenticated, is going to vote based on that. You can have a voter who votes based on whether or not this user has a particular role. So if this user is an admin user, that would be a role on the user object. And the ACL, this is where the ACL is. ACL is this big thing, but all that it is a voter that works for the Access Decision Manager. So if you hit a point in your development and you say, oh, I need an ACL for that, chances are you don't. You just need to write your own voter. So if you only want to allow a user to edit this object if they are the owner of that object, if that object references that user as owner, you can write a voter that encapsulates that logic. You don't have to open up the whole ACL and start managing all these access control entries. Questions? the factor. So I didn't talk about security factories, but that's part of the configuration mechanism. It doesn't have to create both of them, and it just has to provide both of them. So if you, for instance, this layer, the authentication listeners that map from the request onto the token, if you get username and password from a form submission is one way. If you get username and password from your from the header, the www authorize or whatever it is, that's another way. But once you grab the username and password and put it on the token, they can both be handled by the same authentication provider. So there are instances where one listener is going to have its very own authentication provider on the other side, and there's never going to be any reuse. There are other instances where there will be more reuse. Correct, yeah.
Can I ask, what are some of the bundles that extend the architecture that you just described that we can use on our projects to maybe for different data, or that you have run or have had a chance to use, or that you recommend? Like which bundles? Because I know there are some bundles that extend these.
I write my own, honestly, because with these bundles, a lot of bundles I will read and they do a lot of things that I don't need done, or they don't do what I do need done. So for instance, back in the day, it works better now, but the Facebook bundle, I think, there wasn't a mechanism for, once that request comes in, if that user doesn't already exist in our database, to create a new user. So that would happen inside of the authentication provider. If the logic for your application is that if we have an authenticated Facebook user come in and we don't have a matching user in our database, we want to create one automatically then, that would happen in the authentication provider. Generally, the Friends of Symfony ones, I would probably refer you to Twitter and Facebook, but they're not perfect. They are a little, there's a lot in there that I don't use. I can show you just what I've written though too. Yeah. Security Extra. I'm a big fan of annotations, so yeah. So once with the voter, when you start grokking voters, then you can, so the combination of voters and the parameter converters that come in the Framework Extra bundle, and then the security annotations that come in the Security Extra bundle, those three things come together, and you have an object coming into your action, into that callable, and you can annotate like owner. You can say secure param, name the parameter, and then you need to be the owner of that, and then eventually that'll thread through to your owner voter, and all that does is compare that reference from the object to whoever the owner is with the user that's on the token. Jordy's?
Yeah.
I only looked at that this morning, honestly, and so I can't. It doesn't make any huge foundational changes. I think it's kind of some sugar on the top. I am so happy this is done. OpenSky is hot. If you know anyone in Portland that wants to work with me, I'm going to be having a few interns. So if you have a relative who's in school and you don't go to school in summer, so you come to Portland and be an intern, you can come work with OpenSky, and we're actually hiring full-time folks also. Keep Portland weird and rate my talk. Thank you. and thank you, Nathan and Leon.